Well, Unit 1, Lesson 7, we're going to solve first-order linear differential equations. I could call that FOLDE, using an integrating factor. This is very cool how it works out.
Well,
yeah, it's cooler than you might think.
Well,
it's actually pretty nifty the way this works.
well,
Yeah, it is. It really is.
yes, indeed.
Okay, so let's see it. Well, a first-order linear differential equation is any that can be arranged into a format like this, where we have a function of x times the derivative of y with respect to x of some function, plus another function of x times y, which is itself a function of x, and finding y as a solution equals some g of x. But it's funny, I say any of this form, but what we're actually going to do is divide both sides by this a1x, and so then we'd have dy dx plus a0x over a1x, and I'm calling that px, times y equals g of x, well actually equals g of x over a1 of x, and I'm calling that f of x. So any that can be written like this, and then we can simplify to this. Get it?
Yes, indeed.
Okay, great. Anyway, the solutions will be on some interval where p of x and f of x are continuous. So, the following property is crucial to first-order linear differential equations, right? First-order linear differential equations. Any solution, dy dx plus p of x times y equals f of x, can be written as y is yc, sometimes called y complement, sometimes called the complementary solution, sometimes just called yc. But yc is the solution of what's called the homogeneous equation. Instead of f of x, 0 on the right hand side. So yc is the solution of that homogeneous equation, and yp is the solution to the equation with f of x on the right hand side. So we could say a particular solution and the part of the solution that makes it the general solution in a way. So yc is the solution of the homogeneous equation, dy dx plus p of x equals 0, and yp is the particular solution, and our solutions y will be of that form. Solution of the homogeneous plus a particular solution of the equation. I hope you understand that.
You don't know how to have fun.
You're right, but I think if once you see this, you'll probably really like it.
Yay!
Good. Okay, so let's go a little bit further. The homogeneous equation can be solved by separation of variables, and you knew that. It's from the lesson 5. So all you have to do to solve this one by separating the variables is take the p of x times y, subtract it from both sides, divide both sides by y, multiply by dx, and you have 1 over y dy equals negative px dx, and then integrating both sides, now we're going to get a constant of integration, then ln of absolute value of y equals integral of negative p of x dx plus some arbitrary constant. And so now you recognize that we can make both sides exponents for e to the ln of absolute value of y, we'll call that yc, and e to this stuff is e to the negative p of x dx, e to the integral of negative p of x dx times e to the c. Remember why it's that? And that e to the c is here. That constant is really e to this c. So the constant went through a few changes, and I hope you get that.
Woo!
Oh, I guess you did. All right, so we can always find our yc.